Just a flat plane and an angle measurement to a star. That's all that's being done. So all this nonsense about how it could be done on a sphere, yeah, it might be. But it isn't. Looking for them to have a blazing row with us about anything. I'm more trying to assess their consideration on the R situation. Our argument has been the same for 2 straight years, and it's got quieter and quieter and quieter and quieter. Now we've got people, so-called chat skanks. And I want to know, regardless of your arguments, our argument is that you don't have an R value. What have you got to say for that? Anything?
All I hear is silence.
Well, they're in a position, let's just take the Sextant at the moment, where all they can do is reaffirm what they've already claimed concerning the Sextant, which is what Bob the Science Guy's latest video did. He has 1 of 3 videos coming out. The first one came out. It's just a reaffirmation of what the claim is to do with the Sextant. So, just using that as an example, all they can do is give back the same claim that we originally refuted. The best they could do when it comes to a radius value is say, oh, it's been measured loads of times, or you don't understand it, or there's thousands of ways to measure it. But it's all vague. There's no
Bob,
specific.
the science guy? Why you even talk about him, dude? He can't even say conundrum. And he thinks there's Coriolis effect when you're standing on the Earth or driving a car, you experience Coriolis. This guy is he's scary retarded. See, this guy's not lying. Look into his eyes. That guy is a scary retard fur, man. I'll tell you. He scares me. So why are you even talking about it in his stupid video?
Well, I'm just bringing it up because that's the rebuttal. That's the first rebuttal to the Sextant we've got.
A rebuttal from a guy that can't say conundrum?
Well, that's not my fault. I mean, just giving you the rebuttal that was given from their side.
I watched that video, Brian, after you sent me the link, and it's so basic, and it's just a rehashing of everything I've seen before. And he did not address the GP, the circle of equal altitude, the straight radius line covering thousands of miles of the surface of the Earth. He did not address any of those things. It was such a basic thing that you can just go anywhere on the internet and get. It's just their claims again of R.
Or just what did they get? What did he claim?
Well,
go on, Brian.
It's only the first of 3 videos, so he might be addressing the line of position in the next 2. I don't know, but I leave Tent to tell you. Tent, you go ahead.
Yeah, I mean, what I got from it was boring, and what QE said about his eyes. I just studied body. I'm a salesman.
Stop. Right. So far, I've had 2 people tell me that you reaffirmed the original claim. Right. Fine. What was the original claim in that case? He reaffirmed it by saying what?
Center of the Earth is where the reading's being taken from.
He assumed R.
What?
Yeah. Central angle. That's why I put up that slide, because that's the only way you can get a 90 to work.
Wow.
It's not just an assumption of R, though. It's an assumption of the heliocentric model.
Yes.
Because as part of his claim was parallel sun rays, and that comes from the claim that the sun is a big, massive, huge ball of plasma, 93 million miles away. So that also, let's say, cognitively makes it okay for them to put the angle in the center of a globe. Now, logically and realistically, it doesn't work, but cognitively, it allows them to do that.
Yeah, Brian,
you mean that time he's trying to demonstrate it's parallel with all the mirrors? Right?
Brian's onto something here, which is good. Since the sun rays come in parallel, and since we can achieve the angle that we want from the center of the Earth, the globe, All these two presuppositions is the whole talk he had, basically.
So in other words, it was a video about how he's going to beg the question.
Yeah, the whole video was begging the
course.
question. It was
Yeah.
boring and laughable.
Okay.
But it's also a funny attempt, though, to kind of like still try to keep reinforcing the idea of these lights being infinitely far away and thus parallel based on a presupposition of sphere, when in reality, yeah, the lights are kind of weird because we can't even really pinpoint them down to specific lights coming from specific positions,
Hold on.
right? And he's playing with that,
Hold
but
on.
he's still presupposing R.
Sorry. Okay, so this was a redress to the claim that you're going to draw out a 90 on a flat plane. Now, I know you've already answered this, so hence I know where I'm leading you. But in regards to how it's actually done, regardless of when I assume that I can get 90 degrees from a presupposed centre of a presupposed spherical Earth and that the light rays are coming in parallel, when did he actually address the fact that that is not what's done?
Well, he actually was did the next trick, which is he drew a tangent line that was the short line that we always see on top of a sphere, and saying at this point you have a baseline to zero where it just touches the surface at that point. You know how they draw that short tangent line. I say, great, about a circle of equal altitude that goes on for thousands of miles. Where's the
Yeah.
tension?
Hold on. Where did he? Hold on. Where did he? He drew a tangent. What was he drawing? Where is he drawing a tangent from? What to what? A tangent for
He drew
what?
a tangent. No, well, it wasn't. He called it a tangent line, wasn't it? It was a tangent plane where he put the center of the line on top of the globe. It's just, you know, a tangent plane like in surveying, basically the same thing. Only 2D, not 3D.
A flat plane on a circle. In other words, he chopped the top of the sphere off to give him a flat surface to work with.
Well, no, he didn't draw a chord through it. He just put a tangent on top of it.
I'll go there.
Hold on,
I'll go
Tenth.
there. Take a
Hold on.
screenshot.
Hold on. When you say put a tangent on top of it, is he drawing a chord or is he drawing a tangent? What's he doing?
He's putting a tangent plane, which is the center of the line, the tangent line, will be touching the sphere at one point. And he put it on what looked like the top of the sphere. So he just drew a straight line across the top of the sphere. He didn't draw a chord through it. He just put a straight line on top of the sphere and called it a tangent line. Really what it is a tangent plane. He created an imaginary tangent plane.
I gotcha. So he's got a straight line that's like a seesaw on top of the curve, and the center point of that straight line is the center point of the tangent plane, which is the accurate description you're ascribing when he just called it a tangent. Correct?
Yeah, when he said tangent line, it's not correct. It's a tangent plane, basically, to be more correct term for it.
I understand. And that's going to be his equivalency for the area of equal altitude, right?
Well, that's going to be how he gets his original vertex. You see, this is the thing. Elizabeth Tent was saying a second ago. He'll get his vertex, his 90 degrees, off of that tangent plane. But in his world, the ground is falling away below you all the time. So you'll only get a vertex off of this imaginary tangent plane that he placed on the top of his globe. And that allows him to take that vertex then and move it to the center of his globe using the diameter of the equator.
Oh, this is brilliant. Hold on, someone sent me a screenshot to make this visually obvious.
I did.
This is epic.
I did.
So thank you very much, Tenth. So let me get this straight. Even when he's trying to explain to his audience how it's being done, he's still drawing out a flat surface. Now, let me just, for the audience's benefit, right? See, for the guys in G+, if you can follow along with the last Skype image that was sent by 10th, right? So he's got his 90-degree angle here, right? And he's measuring out to this star, which we're going to call O, although I just think he's just drawn a circle for a star. He's not labelled them individually. Right, so he's got this star closest to where he's got his tangent plane that was just described, this straight line. Yeah? Well, he's doing this so he can actually perform the measurement to do the triangulation. Now, like all of them, he hasn't drawn in the 90 that he's actually going to be drawing to get the GP of this star. Right? He's saying that this star is triangulatable, therefore it's going to meet this tangent plane at 90 degrees. Right? He's got his zenith being the centre position of this tangent plane, correct, Brian?
Here, let me give
Yeah.
you background. The 2 zeros is actually the sun. It's the same sun. What he's saying is, since the sunlight comes in parallel, it's actually one sun. But the sun on the lower one, where it says GP, that's where its location is on their spherical model. So that's where the sun is. But here you are on top, and it says 90, and it's got your zenith coming down to the center of the Earth. Whereas the sun, its zenith is coming in on an angled version to the same center of the Earth. That's what he's trying to show here, the corresponding angles, because sunlight comes in parallel.
I see. So he's saying as you move, as the sun moves, its light shining onto the Earth hasn't changed its angle. And he still needs this straight line. I'll just get back to my original point. What he's got below this angle is how much it doesn't work on a sphere. This differential between this straight flat line and the curved line beneath it. That's the differential in terms of how much it doesn't work. Why? Well, because what's actually done? Well, none of this spherical stuff is taken into consideration because you've already got a flat plane. So you don't have to do anything like this. You just take the plane surface with parallel lines running to each of the GPs of each of the lights that you will measure on that flat surface. So the consideration for this curved line is nothing more than his diagram showing how much the surface being measured for the angle that's required to do the triangulation doesn't jive with the curved line beneath it that isn't being used.
Yeah, if you notice the corresponding angles of the one black line coming in between the two parallel black lines having the same angle, the one in the lower one is the center of the Earth, and the one on the top one having the same angle is the top of the Earth. So he drew that inside the circle there. So that's what he's trying to show here. But again, that's the problem. You need R and you need sunlight to be parallel, and you got neither. So he's done.
But even with the claim of power, like I know it's total nonsense, the whole parallel sunlight thing. If you look at his diagram there, this is absolute evidence, right, from him, right, back to him, that if you take the angle from that 90-degree tangent plane at the top of his sphere to the globe or to the sun that's matching the angle coming from the center of his sphere, that changes your angle immediately. But he's trying to claim that it goes back to heliocentric belief that the sun is so big that anywhere you point towards, it's like the whole thing with Polaris. Everything is pointing up the way towards Polaris. No matter where you are in the northern hemisphere on our globe, up the way is always directly towards Polaris. So technically there's no angle to Polaris because everything is a straight line up to Polaris, because they think Polaris is this monstrous star that's so huge that everything goes up the way you can't miss it, kind of thing, which if you point straight up in the air. That's their claim. The same thing is happening here with the sun. But I said to him, I corrected him on the whole angle thing. I said that changes the initial original angle. It makes it completely pointless. Why would you take this initial original angle, move it to the center of your sphere, and then have to throw it out again? Because you have this new angle.
Correct.
And his claim in the video was that basically the claim, without making the claim, he insinuated it, that parallel sun rays that don't happen, these parallel rays, right, are only because they believe they have this huge sun and it's so big, right, that even though it's 93 million miles away, by the time the rays of that sun has hit the globe Earth, it hasn't even hardly started, the inverse square law of light hasn't even hardly started yet. This is what they want you to believe. So any direction in the same angle from any position there that he sends a line out is hitting the same thing. But the sun has an angular size in the sky. No matter what claim you make about it, it has an angular size. So if I take an angle to the sun here, and I drop that angle to the top of a building, a high-rise building, right? And I drop that angle down to the bottom of that high-rise building, and I take the angle again, put the angle straight out the way, then it's going to be a different, like from my position at the top of the high-rise building, that will change my angle to the sun immediately. You know, it's just begging the question. You know, you can't, it doesn't work. And they don't do it. As Nathan said, they don't do this. They just take an angle and use it. They're not out there in the middle of the ocean drawing diagrams. They're not doing any of that.
But that was my last question. So at what part of the video does he explain where this is actually applied in physical reality? Regardless of his explanation for how he's saying parallel light comes in reality, what I see depicted is triangulation with the sun if you wait a little while for the sun to move. However, on his diagram with the curved surface, it no longer jives, as Brian's just explained, with the original angle that you take. So this depiction could actually have triangulation done with the sun. You just wait for it to move its position. So you can then draw another circle below its GP. But in relation to the original 90-degree line that you've got, not this new angle that's pointing towards the centre of a presupposed spherical Earth. But my point, I'll say it one more time, where's this actually done, ever?
It's not. It's not. That's why the sextant kills it. And the black swan says, you ain't got R.
What he actually did in the video is a little bit later on, he went through how you find your latitude using the sun. And what he actually laid out was pretty okay, pretty good. No one could really fault it. That is how you do it. He showed how it's done and how you use the almanac to do it. And he gave a simple analogy. The point is that what he did was okay, right? But that doesn't mean the stuff he did before that was okay. And as well as that, I sent him a video within my comment from a guy, right? Because I saw Bob do something, giving an explanation of using the sextant, of how you sight the horizon and a star. And the way Bob did it was not the way this other experienced mariner did it. And he said the other way was the way Bob did it was not the way to do it.
The mariner that you sent the video is from the Maryland School of, I can't remember the last part, but this gentleman has
navigation.
Navigation. This gentleman has logged 60,000 miles at sea with the sextant. So I think he explains it, quite well. He's still the glober, but he explains it quite well.
Yeah, well, what this man did originally, right? Now, don't hold this. I'm not going to lay this on Bob's doorstep because he doesn't have that experience. But you can't be. What Bob did with his sextant was he looked at the horizon, if I remember correctly, and then he moved the index arm to look at a star. But that's not what you do. And this man showed it. You literally tilt your head, right? Look at the star, right? You unlock the index arm, right? And you actually bring your head down, and you don't move the index arm yourself. The sextant moves through where the index arm is to get to the horizon, and that's how you properly do it. Now, I don't mind if Bob did it a little bit wrong, because anyone who doesn't use a sextant and doesn't go out on the high seas, they could get that part wrong, right? While they're giving a brief description. I don't mind that. But when I sent him the video about it, he tried to claim that it was the same thing as he was doing. So he showed no humility.
Well, Brian,
you're wrong.
Let's not skip the bigger point of that. The purpose of bringing the sun down to the horizon and doing the rocking motion to where it's barely touching the surface of the horizon. Why is that even being done?
Get an angle to measure the angle.
Right. To what? The GP of the sun over the earth at that precise moment of time. That's why you have to go to right away and say, what time is it? And you start with the seconds first, then the minutes. You don't look at the minute, you look at the second at the chronometer, then the minute, and then you look at your degree mark on the sextant. So the whole purpose, let's just stay here for 20 seconds. Why do you do that? So that you can bring the sun's actual position over the earth to get its GP, so you can draw your circle of equal altitude, which gives you a straight radius line to you once you figure out the azimuth and the bearing and go through the steps of the line of position. That's thousands of miles.
Exactly. This is always going to boil down to the exact same thing. You have a straight line between you and the GP of any star that you triangulate with. Now, what is the GP? Well, it's where it meets that straight line at 90 degrees. In other words, the point directly below that star. Well, every single star in every single example, measured or otherwise, has a presumed 90-degree angle between you and it at the bottom of it. That's called its GP. So you've got a flat plane around you in all directions for this to work. Now there's no, well, if we consider that the horizon's a 90-degree line that gives us a flat plane, and we transpose that flat plane up to the top of a sphere, then we can consider that light coming in parallel. It's like, none of this is done. Just a flat plane and an angle measurement to a star. That's all that's being done. So all this nonsense about how it could be done on a sphere, yeah, it might be. But it isn't.